All right, today we're going to be adding and subtracting polynomials. Most of the stuff is just combining like terms. The first half of the notes, though, we kind of have some vocabulary to work through. So if you could, at the top, go ahead and circle where it says degree. Degree is just going to be the exponent of the variable. So if I have an x squared, that's going to have a degree of 2. Regular x, remember that there's an invisible 1 as the exponent for just a regular x, so that has a degree of 1. To find the degree of an entire polynomial, so a bunch of things being added together, you just take the largest degree, so you're looking for the biggest exponent. So with the example that I gave, this big polynomial here, all I want to do is look for the biggest exponent, which is 4. So the degree of the entire polynomial is going to be 4. So filling out this chart, so with this first one, I just have 6. So 6, since it doesn't have a variable, that means it has a degree of 0. Remember that what matters is the exponent of the variable. So if there's not a variable, the degree is 0. The name based on the degree, so classified by degree, that I would name it a constant function. The number of terms is just the number of things that are being added together. So in this one, there's just one thing, so there's going to be one term. And so if I classify it by the number of terms, I'm going to call it a monomial. So the name based on the number of terms is a monomial. With the next one down, again, I've got negative 2x. So again, the invisible exponent is a 1, so this has a degree of 1, which makes it a linear function. So based on the degree, it is linear. Again, the number of terms, the number of things that are being added together, there's only one thing there, so it's going to be 1, so it's still going to be a monomial. The next one, again, the first thing I want to do is I want to find the biggest exponent of the variable. So this one has an exponent. The variable has an exponent of 2, so its degree is going to be 2. That's going to make it a quadratic function. The number of things being added together, this one has 2 different things being added together. So it's going to have 2 terms, and it's going to be a binomial. The next one down, again, biggest exponent is going to be that third power. So the degree is going to be 3. It's going to be a cubic function. The number of things being added together, there are 3 different things being added together. So there are 3 terms, and that'll make this a trinomial. And then the second to last one, again, the biggest exponent is a 4. So that's going to be a quartic function. There are 2 things being added together, which means, again, it is a binomial. And then the last one, biggest exponent is 5. So it's going to be a quintic function. There are 4 things being added together, and so once you get over 3, everything else is just a polynomial. So everything after 3 is just called a polynomial. So 4, 5, 6 terms, it's a polynomial. Okay. Right below there, again, standard form. So standard form, go ahead and circle it right underneath that big chart, is when my terms are placed from largest to smallest exponent or degree. So it's going to go from the biggest exponent to the smallest exponent. Make sure the one thing that we do is that the number has to go with the variable. So with this first one, when I rearrange this, I want the x to the third to be first, the x to the second to be second, and then this 3 to be last. So just make sure that the signs go with it. So I'm going to put x to the third first, because that's the largest exponent of the variable. I'm going to put the x to the second first, so it's going to be negative 4x squared. If you wanted to put it as minus 4x squared, that'd be fine as well. And then the last one is 3. And so I put it in standard form, and then if I wanted to name this based on degree and based on the number of terms, the degree is going to be 3, so it's going to be cubic. The number of terms, there are 3 terms, and so it's going to be a trinomial. So this thing is a cubic trinomial. With the next one, again, same thing. X to the fourth first, x squared second, regular x will be the third thing. The sign of the x to the fourth is a negative 3, x to the fourth, minus 4x squared, that's the next biggest exponent, and then the 3x is positive, so I go plus 3x. Again, whether those subtraction signs are subtraction signs or plus and negative, it doesn't matter. And then if I want to name this, it has a degree of 4, so it's going to be quartic. And then 3 terms, so it is a trinomial. The rest of what we're doing is really just combining like terms. So in all these, what I'm going to do is I'm just going to combine all my my biggest exponents together, and then go in order. So with this, the biggest exponent I have is x to the third, and so I'm going to underline all the x to the thirds. Just be careful with signs. So 5x to the third plus negative x to the third is going to give me 4x to the third. Next, my x squareds. So I've got my x squared there and my x squared there and my x squared here. We can double underline all those. So when I add all those together, 2 plus 3 plus 4 gives me, 9? Plus 9x squared. My regular x's are next, so I can triple underline my regular x's. And so when I do that, combine those together, it's a negative x plus a negative 4x gives me negative 5x. And then the last thing is just all my regular numbers. I can just go ahead and circle those. So 7 plus negative 8 should give me positive 6. And that's my answer. Again, if I wanted to name that based on degree and number of terms, it'd be a polynomial because it has 4 terms. And then based on the degree, it would be cubic. With the next one, same thing. Add together, my biggest exponent is x to the third. So I have 5x to the third. Combine together my x squareds, I get 3x squared. All my regular x's, I get 2x. And then all my regular numbers, a negative 5 and a positive 6 gives me a positive 1. Again, naming that, it would be a polynomial, and it would be a cubic polynomial again. Go ahead and flip over to the back. On the back, whoops, I think those are, yeah, whoops. Here we go. So this is the biggest thing with doing this is show these 2 steps. Sometimes we try to skip steps and just subtract, and usually we end up doing it wrong. So the very first thing I want to do is I want to distribute, and then I'm going to add my 2 parentheses together. So the very first thing that I'm going to do is I'm going to treat this subtraction of 1 like it's a plus and negative 1, and I want to distribute it to everything in the second parenthesis. So I get negative 2x squared plus 5x minus 5, and then I'm going to add it to negative 1 times negative 2x. It's going to change the sign of everything in the second parenthesis. So minus 3x and then plus 7. Once I'm here, then it's the same exact thing that we did. Biggest exponent is 2x to the third. It doesn't have a match. Minus 2x squared. Again, doesn't have a match. I've got my x's that I can add together to get plus 2x. and then my regular numbers, which gives me plus 2. So there it is. It's a cubic polynomial again. With the last one, again, same thing. Change this to be like plus a negative 1 since I'm subtracting, and then go ahead and distribute it into the second parenthesis. I get 3x squared minus 4x plus 5x to the fourth. Then when I distribute, I get negative 4x squared plus 6 plus 9x. Then I can combine all my terms together. 5x to the fourth is the biggest. It doesn't have a match. I can put my x squareds together, which gives me negative 1x squared, or just negative x squared. Our regular x's, which gives me plus 5x. And then my regular number, I just have 1, which is a plus 6. That would be a quartic polynomial. Degree is 4, so it would be quartic, and then polynomial that has 4 terms, so it is a polynomial.